So now we'll take a look at hexadecimal. So what is hexadecimal? You'll hear this a lot in computer terms. You'll hear it a lot in graphic design terms. Hexadecimal numbers represent colors often. You'll see it used in cryptography. You'll see it used all over the place. So hexadecimal is a base 16 number system. Ours is base 10. Binary is base 2. Hex is base 16. A lot of times this is used to represent a binary string. We can take a nibble into a number between 0 and 9, or a character between A and F. Because 0 through 9 doesn't have any other symbols to represent 10, 11, and 12 to repeat, we're going to start using letters. So in order to get 16 numbers in a set that we can repeat, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And that's our 16 symbols that we use to express the set that's hexadecimal. Usually hex, when it's written, is prefixed with a lowercase x to denote that it's hex. You can see XFF is X1515, or X0B is X011.
Here's a list of the valid hex values. So like Brian said, 0 through 9 represents what they are, 0 through 9. And then A through F represents 10 through 15. Here's an example of how to convert a binary number into hex. So what we're doing here is we're taking an 8-bit binary string and we're splitting it in half. The first 4 bits, or the first nibble, goes over here, and the second nibble goes over here. So let's take 0110 and convert that to a number, and this equals 6. Now let's take 1110, convert that to a number, and that's 14. So when we combine these two numbers, 6 is between 0 and 9, so it retains its numerical value. However, 14 is above 9, it must be assigned a character value, which is E. So the outcome of this conversion will be 6E or X6E.
Done. It was that straightforward.
Yes.
Now you can convert to hex.
And here's just another example where we take a nibble that is all on. So in 4 bits, 15 is the highest value. So you can see where that F comes from, because nothing can be higher than F. So in this case, we have 15, we have 11, F and B, or XFB. So, Brian, how do we take a hexadecimal value and convert that into binary?
Alright, well, just like a squirrel breaking down its problems into small little acorns that it can store away, we will similarly break down this problem in small little acorns.
Okay.
I don't know why I said that. 6E. The 6E is just a 6 and an E. E's value is 14. Let's convert 6 to binary, then we'll convert 14 to binary, and we'll reconstruct it into our 8-bit string. So we take a look at 6, and we go through the technique that we went through before. We start with 6, divided by 2, there's no remainder, it's off. We drop the 3 down. Divide 3 by 2, we have a remainder, it's on. And so on. 1 is on, 0 is off. And we do the same thing with 14. 14 divided by 2 is 7, there's no remainder, 0. 7 divided by 2 is an odd number, so it has a remainder, it's 1. Odd number, it's 1. Odd number, it's 1. Even number, it's 0. When we write out the binary, we write it out bottom up. So 6 becomes 0110, 14 becomes 01110, but we drop the leading left 0.
The reason why is because we can only have 4 bits.
Right, and it doesn't affect our positional value. When you convert from hexadecimal to binary, if you have more than 4 positions, it will always be 0. So that last one will always be a 0. So that gives us 1110.
Now let's take that other example, FB. We take F, convert that to 15, B, convert that to 11, because we just know that those are the values. And we do that process that Brian explained, and we convert 15 to binary, which is all ones. Then 11 to binary, which when we read from the bottom up on that chart there, it's 1, 0, 1, 1. So now we have successfully converted this to binary.
Easy.
And if you wanted to get the decimal representation, take this and plug it into that chart, that binary number, and now you have the decimal, or the integer, that represents.
Absolutely. This now allows you to go from a decimal number to a binary and back to hexadecimal to back to binary, up and back every which way you could possibly want. So you should have no hesitation being able to walk into a room full of robots and say 01110111110. Because this will be important in the future when all the humans are dead. And there's only one kind of dance.
The robot. The robo boogie.
Oh, and the robot. That too, also.
So thanks for watching, gang. We'll see you guys in the next one.